cursor comes here. Again has more tokens. True. Next token. Java return, cursor comes here. Again has more tokens. False. Okay. Now, that is I want to do. If you want to call those methods, which class object required? String tokenizer object required. What we have tried? String tokenizer st equal to new string tokenizer of yes. Okay. Now, until you get a false, you have to iterate. Until you get a false, you have to iterate one by one. Then what we have to do? While st dot has more tokens, then now here has more tokens. What is the return type? Boolean type. True or false? True means it will enter. False means stop it. Now, next token method return type, what is there? See, next token, string. Then what we have to write? String, something s2 equal to st dot next token. Okay. Now, system dot out dot println s2. These two lines can I write as a one line? What we have to write? st dot next token. Okay, like this. Now, you observe. First, welcome to Java. It is a one string object created. This object referred by s, that is passed as a parameter to string tokenizer constructor, that is referred by st. With that, has more tokens. True, it will enter. See, first of all, cursor is here. St dot has more tokens. True, it will enter. St dot next token. Welcome return. And printed. Cursor comes here. Again, st dot has more tokens. True. Next token. Java print to printed, cursor comes here. Again, next token. Java printed, cursor comes here. Again, st dot has more token. False. See, file, save. Token by token, extracted, save. Java demo. See, welcome to Java. So, welcome in first line to second line, Java third line. Okay. Write this one. Program to iterate token by token. Program to iterate token by token in a given string. Program to iterate token by token in a given string. Is it our program to iterate token by token in a given string? Say, first of all, cursor will be before welcome. Count as more tokens. True. It will enter. Next token. Welcome printed. Cursor moved here. Again as more tokens. True. Next token. Two printed. Cursor here. As more tokens. True. Next token. Java printed. Cursor will be here. Here. Again as more tokens. False. Stop it. Like this, you can iterate token by tokens here. Is it over? Now, this is about string handling. Here, string handling assignment also I'll share in Google Classroom. Okay. Now, here it is also string, but string array this is. Till you didn't study this one. Okay. Now, main method, is it accessible outside the package? Is it accessible? Yes, because public. Is it instance method or class method? Because static. What is the return type of main method? Void. It doesn't return. Okay. How many parameters? One. Which type? String array type. So this is like this. You can write here also already know. Three places you can write. So array operator, you can write here also. You can write here also. You can write here also. All are valid. This is also valid. Okay. String array type. Now, how to pass arguments to main method? That is, I'll explain now. The next concept, note on. Command line arguments. Command line arguments. Command line arguments. Note on. The arguments that are passed at the command prompt. The arguments that are passed at the command prompt are called command line arguments. The arguments that are passed at the command prompt are called command line arguments. The arguments that are passed at the command prompt are called command line arguments. The arguments that are passed at the command prompt are called command line arguments. Example. Java demo. Suppose here I'll pass welcome to Java. These arguments are called command line arguments. This index is 0, 1, 2. Index 0, 1, 2. Say, while executing program, you can pass some arguments. Those arguments are called command line arguments. It is 0, 1, 2 index. The arguments that are passed at the command prompt are called command line arguments. So it is command line. Java demo will execute. While executing, we can pass some argument. These arguments are called command line arguments. Here array index 0, 1, 2. Okay, like this, n number of arguments you can pass. Next point. Command line arguments are received by main method only. Command line arguments are received by main method only. Command line arguments are received by main method only. Is it over? Here, main method can receive. Suppose at the command prompt, I'll pass like this: Java demo. Welcome to Java. I'll pass. These are three arguments I'm passing. Received here. Okay. Now, how to print array elements? All received by array. How to print? For each and answered for loop. What we have write? For string s colon ox. Next. Yes. From this array, one element copied and printed. File, save. Compilation, execution. I'm passing welcome to Java. Suppose I'll pass welcome to Naresh Technologies. Now, if I pass like this, what will happen? Will it print 10, 20, 30, 40, 50 or error? Will it print or error? Now, here which type it will take? Now, if I write like this, is it valid or not valid? So it will understand like that, it will print. All are strings only. Now, at the command prompt, now whichever type you want, you can pass, but all will be considered as a strings only. All are strings only. It will receive string format, but you cannot perform operations, addition, subtraction like that. You cannot pass because string these all. Okay, addition if you perform also, concatenation done. Now, write this one. Example. Here, array will receive whatever you pass at the command prompt, all received. From that, one element copied, printed. One element copied, printed. Okay. This is command and arguments concept. Now, what I'll do, just observe. See, at the command prompt, you can pass numbers also, floating point numbers also, characters also, all are treated as strings only. Okay. Suppose system.out.println args of 0, first argument, plus args of 1, second argument, args of 0 plus args of 1. File, save. Compilation. Execution. Here, I'll pass Taj Mahal. What will happen? Taj plus Mahal. Taj Mahal. Concatenated. Java demo 1020. Will you get 30? No. 1020. Concatenated. Okay. Write this one. Write this program. So execution also note down. Compilation, execution like this, write it. Now 10 is a one string, 20 is another string, two strings are concatenated, you will get a 1020. Taj is a one string, Mahal is a one string, two strings concatenated, Taj Mahal. Is it over? Taj is a one string, Mahal is a one string, two strings concatenated, you will get a Taj Mahal. 10 is a one string, 20 is a one string, both are concatenated, you will get a 1020. Now, suppose I want to perform operation on integers, we have to convert into integer. Conversions purpose, we require next topic, wrapper classes. Okay. Next. Is it out? How to get 30? I'll show you. How to get 30? I'll show you. Okay. Now, next concept, wrapper classes. See, why the given string array here? If integer array is there, suppose assume integer array is there, can you pass float array? No. Can you pass string array? No. Suppose float array is there, can you pass integer array? No. Can you pass string array? No. But string is there, all you can pass. That is the reason they given. Now, later you convert according to your requirement. Now, your parameter string array. Now, any type you can pass. Later you convert according to your requirement. Okay. That purpose of wrapper classes we use. No. How many primitive data types are there? How many primitive types? What are those? Byte, short, int, long, float, double, char, boolean. For every data type, one class is there. That class only wrapper class. Each of Java's 8 primitive data types has a class. Each of Java's 8 primitive data types has a class. And those classes are called wrapper classes because they wrap the data into an object. Each of Java's 8 primitive data types has a class. And those classes are called wrapper classes because they wrap the data into an object. Each of Java's 8 primitive data types has a class. And those classes are called wrapper classes because they wrap the data into an object. I'll explain. Primitive data type, wrapper class. For every data type, one class is there. That class is called wrapper class. Byte, short, B capital. Class is capital letter, no? But int place, integer is there. Long place, long is there. Primitive data type, wrapper class. So here byte, here capital byte, capital B. But two class names are different. Int place integer, char place character. Remaining same names are there. These all classes we are calling wrapper classes because they wrap the data into an object. How it will wrap, I'll show you. For every data type, one class is there. Every data type. Okay. Every data type, one class is there. Every data type, one class. Now, 8 classes, the above all classes are the part of java.lang package. The above all classes are the part of java.lang package. The above all classes are the part of java.lang package. Okay. Every class, every data type, one class is there. Now, is it over? Now, if you want to see the profile, Java P, java.lang.integer, see, integer class profile. Java P, java.lang.float, float class profile. That is, we have. Now, first, why we are calling wrapper classes, I'll explain. See, whatever we got, that is a copied in Notepad, one file. Present these two required. With this, I'll explain. It is constructor. It is method. Here, I'll remove package name. It is used to convert into integer. Note on this one. It is used to convert integer to int. It is used to convert into integer. It is used to convert integer to int. Into to integer, integer to int. See, I'll explain. Suppose, don't write. Writing is over. See, int x equal to 10. Okay, int x equal to 10. This one, I want to convert into integer class. What I given? Constructor or method? Constructor. When constructor is called? What we ought write? integer I equal to new integer of x. So here, what will be happen? See here, int x equal to 10. X value 10. Now here, new integer of x. Then what will happen? Integer class object created. This object referred by I. This object referred by I. What I contains? Hash code. I contains hash code. The value of x wrapped up into an object like this. So the value of x wrapped up into an object and placed here. This is called wrapping. The value of x wrapped up into an object and that object referred by I. I contains hash code. What is the need of wrapping? Further, some application, what will happen? Client to server, server to client. You can transfer only objects. At the time, primitive type doesn't support it. In that situation, we'll wrap, we'll send. Again, we'll reverse conversion. So int x equal to 10, like that, memory allocated. New integer object created. The value of x placed in object. That object referred by I. Now, I is primitive type variable or reference type variable. What it contains? Hash code. But system.out.println I, if I write 10 printed, it is hash code not printed. Reason, toString method. Here also toString overridden. Okay. Now right here, this is nothing but converting primitive type to reference type, like primitive type to reference type converting. It is an example like here what we are using, constructor. Converting primitive type to reference type, what we are using, constructor. Write this one. Wait. After class. Is it over? Now, here system.out.println I, if I write, when toString method is called, whenever object or object reference is passed as a parameter. Any object reference. Here, if you pass I.toString called, this toString is there in the integer class. If not there, super class. Like that. Here, there, that's what prints 10. See. First, is it over? Here, what we did is primitive type we converted to reference type. Okay, the value of X wrapped up into an object. That is wrapper class. Now, suppose integer I equal to new integer of 10. Like this we have. Okay. Here. This is I want to convert into primitive type. One method I given. What is the method name? See. Int value. That method return type is integer. Is that method is accessible? How do you know? Give me answers. All are not giving answer. Now integer to int I want to convert. Integer to int I want to convert. Which method? Int value. That method, is it accessible? How do you know? Public. Is it instance method or class method? Instance method. How do you know? There is no static. How many ways to access? What are those? Which class object record? Already created. That object referred by I. With this I can I call? What is the return type? What do you write? Int some X equal to I dot int value. Okay. Now here new integer of 10. One integer object created. Here integer object created. In this object 10 stored. It is referred by I. It is referred by I. It contains hash code. It contains hash code. Now the value extracted from object and placed in X. Reverse. Now this is nothing but reference type to primitive type conversion. Ready, son? Reference type to primitive type. Is it over? Now converting primitive type to reference type. Converting primitive type to reference type. Constructor record or method record? Constructor. Converting reference type to primitive type. Method. Which method? Which method? Int value. Now one class I given. Like this 8 classes. Suppose float is there. What will be there? Float f equal to new float. Something you will write. Float y equal to f dot float value. Like that will be there. Okay. Now Java 1.5 version onwards, constructor not required, method not required. They totally changed. Two concepts introduced: auto boxing, auto unboxing. Next, write it. Auto boxing. Auto boxing. The process of converting primitive type to the corresponding reference type. The process of converting primitive type to the corresponding reference type is known as auto boxing. The process of converting primitive type to the corresponding reference type is known as auto boxing. The process of converting primitive type to the corresponding reference type is known as auto boxing. The process of converting primitive type to the corresponding reference type. Corresponding means into to integer only, float to float only, double to double only, char to character only, like that. Now, example, int x equal to 10. If you write integer I equal to x, you can write. So, convert here, constructor is not required. Directly you can write x. This line, what will happen? Internally object created, in that object x placed. So this line is called auto boxing. Automatically, auto means automatically, box means object. The value placed in object, that is called boxing. The value if you place in a box, that is boxing. The value if you remove from box, unboxing. Auto boxing, auto unboxing. Two features introduced. Okay. Say mobile unboxing reviews, you'll call, no, like you'll see, no, like that. Now here a box, nothing but object. The value placed in object means boxing. The value removed from object means unboxing. Boxing, unboxing. Auto means automatically. So the value of x placed in object, but where is object? Implicitly done. That is only automatically done. Auto boxing. Now, whatever I written previous, that is, this is same now. Now consider is not required. Okay. Next, auto unboxing. The process of converting reference type to the corresponding primitive type. The process of converting reference type to the corresponding primitive type is known as auto unboxing. The process of converting reference type to the corresponding primitive type is known as auto unboxing. Integer I equal to new integer of 10. Now int x equal to I. This line is called auto unboxing. Integer I equal to new integer of 10. Int x equal to I. That is auto unboxing. The process of converting reference type to the corresponding primitive type is known as auto unboxing. The process of converting reference type to the corresponding primitive type is known as auto unboxing. Say here, from object value extracted and placed in X, that is unboxing. Next, both auto boxing and auto unboxing features are introduced in JDK 1.5 version in 2004. Both auto boxing and auto unboxing features are introduced in JDK 1.5 version in 2004. Both auto boxing and auto unboxing features are introduced in JDK 1.5 version in 2004. Auto boxing, auto unboxing introduced in 1.5 version. 1.5 version introduced. These two. Okay. See, now consider is not required, method is not required. We can perform. Consider is not required, method is not required. We can perform operations. You observe here. Int x equal to 10. Integer I equal to new integer of x. Okay. This is up to 1.4. We written like this. 1.5 onwards like this. But actually, what x contains? Data 10. What I contains? But like this, if you assign, actually illegal. But internally, what will happen? One object created, implicitly done. That is automatically done. The value of x placed in object. That is auto boxing. Automatically, the value of x placed in object. That is auto boxing. Now, you will write like this. Integer I equal to new integer of 10. Int x equal to I. Here actually this object contains 10. The value extracted from object, that is placed in x. From object value extracted, that is unboxing. This is automatically done. That's what auto. So here what I contains, but what x contains? Data. Here as code assigned to data. Actually it is illegal, but internally done. That is implicitly done. That is. Okay. And also if you print like this, system.out.println I, implicitly what will happen? ToString method called. Say file, save. ToString method called with the 10 printed. This is removed. It is not just observe. Writing like this is not recommended because already auto boxing feature is there. Say what's this system written? Warning. It is not error. Warning. Integer of int is and it has been deprecated for marked for removal. This constructor they are planning to remove from library. That is removed for they are marked for removal. That is called deprecated. But it is not error. Warning. It is valid only. Now you can run. Okay. What they are saying, don't write like this. Write like this they are saying. Because auto boxing. Now it is also auto boxing. Directly if you write also auto boxing only. See error not warning not coming. Now value of 10 automatically placed in object. Here implicitly toString method called. The toString method is there here. Java p java.lang.integer. Here toString method is there. Not this one, not this one, this one. This toString method called. Here, with this toString method, content of object string format printed. Okay. Now, if you print 10, this I.toString 10 printed, object value printed because toString method overridden. Okay. Now, with this number formatting also possible. Here we have some methods: octal, hexadecimal, these all. See, I'll show you. With wrapper class, these conversions also possible. Say, suppose example, the value is 30. By default, this base is 10. It is decimal number. This number is called decimal. Decimal number, if you want to convert into binary, what will do? Divide by 2. You will write like this. 2 15 30. Remainder 0. Uh, 2 7 14. Remainder 1. 2 3 6. Remainder 1. 2 1 2. Remainder 1. Now 1 1 1 1 0. This base is 2. It is binary number. Binary. Now, base is 2. It contains only zeros and ones. That's what base is 2. 10. It contains 0 to 9. 0 to 9. Base is 10. Suppose this is, if you want to convert into octal. Octal, how will convert? Divide by 8. 8 3 24. Remainder 6. Here we'll take bits like this. Okay. 3 6. Base is 8. This is octal. Next, hexadecimal. Hexadecimal 16. Uh, 16 1 16. Remainder 14. In hexadecimal, 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, 15 means F, 16 means 16 divisible, no? 16 divisible. So 114, 114 nothing but 1 E. 114 nothing but 1 E. Base 16. Here 16 means 0 to 9 will be there, 8 to F will be there. Like that 16. It is hexadecimal. These all no need to write any logic. We have library methods if you want to convert. Right is all. I'll show you how to convert. With library methods how to use, I'll show you. decimal to binary, decimal to octal, decimal to hexadecimal I given. So it is decimal number I converted to binary. It is decimal number I converted to octal. It is decimal number I converted to hexadecimal. So decimal base is 10. So 0 to 9 will be there. 10 digits. Here binary 2, only 2 digits, 0 and 1. Octal 0 to 7 will be there. Hexadecimal 16. 0 to 9 will be there. A to F will be there. Is it over? Like this, if you want to convert, we have separate library. No need to write any logic. Now I'll show you. Is it over? See, here methods are there. To hex string, to octal string, to binary string. These methods. Now write these methods. Here just pack in name I'll remove. To hex string, to octal string, to binary string. To hex string, to octal string, to binary string. To hex string, to octal string, to binary string. Are these methods are instance methods or class methods? Class methods because static. Okay. How many ways to access? How many ways not recommended? When we can use directly? When we have to use class name? Another class. Now, these methods in which class? Integer class. Suppose my class is demo class. Can I access directly? Can I access directly? No. How to access? Which class name? Integer. So you have to call integer dot to x string, integer dot to octal string, integer dot to binary string. Return type is all strings only. Parameter all integers only. Okay. Now you observe. Is it completed? Now here int some x value 30. Now I want binary format. Last method. What we have tried? Last method I want to call. What we have tried? String s equal to what we have tried? Integer dot to binary string of x. Then system dot out dot println yes. These two lines can I write as a one line? Yes. How to write? System dot out dot println integer dot to binary string of x. Okay. Otherwise, directly can I write here 30? Yes. Same style. System dot out dot println integer dot to octal string of 30. System dot out dot println integer dot to x string of 30. Here what is output? 4 ones 0. Here 36. Here 1 E. File save. I'll compile. I'll execute. See. See, it is binary. It is octal. It is hexadecimal. Binary, octal, hexadecimal. Write this program. To binary string, to octal string, to hex string. Is it on? Suppose 410. It is binary. It is binary. How to convert into decimal? 2 power 0 into 0. 2 power 1 into 1. 2 power 2 into 1. 2 power 3 into 1. 2 power 4 into 1. 2 power 4 into 1 plus 2 power 3 into 1 plus 2 power 2 into 1 plus 2 power 1 into 1 plus 2 powers 0 into 0. Okay. 4, 3, 2, 1, 0. Now 2 power 4 into 1, 8, 16 plus 8 plus 2 plus 0. Okay. Now 16 plus 8, 24. 24 plus 4, 28 plus 2, 30. This is decimal. It is decimal. Now 36 octal. 36 octal. How to convert into decimal? 8 power. 8 power 0 into 6. 8 power 3 into 8 power 1 into 3. 8 power 1 into 3 plus 8 power 0 into 6. 1. Here 0. 8 power 1, 8. 8 into 3, 24. 8 power 0, 1 into 6, 6. 30. It is decimal. Reverse I am converting. Hexadecimal 1E. 1E. Here. It is hexadecimal. Here. 16 power 0. 16 power 0 into 14. E means 14, no? 16 power 1, here 16 power 0. 16 power 1 into 1, 16. 16 power 0, 1. 1 into 14, 14. 30. Decimal. Here 10 means cap A, 11 means B, 12 means C, 13 means D, 14 means E, 15 means F. Right, this one? Reverse conversion. Binary to decimal, octal to decimal, hexadecimal to decimal. So 2 power 0 into 0, 2 power 1 into 1, 2 power 2 into 1, 2 power 3 into 1, 2 power 4 into 1. 2 power 4, 16, 16 into 1, 16, 2 power 3, 8 into 1, 8, 2 power 2, 4, 4 into 1, 4, 2 power 1, 2, 2 into 1, 2, 2 power 0, 1, 1 into 0, 0. Let 16 plus 8, 24, 28, 30. Here 8 power 0 into 6, 8 power 1 into 3. Okay. Here 16 power 0 into 14 because E means 14. Like this. Is it over? It is binary to decimal, octal to decimal, hexadecimal to decimal. If you want to print, you observe. Integer E equal to 4 ones 0. Suppose if I print A, what is the output comes? Same output comes. Okay. But just 10B if you write, it is binary. Now you'll get a 30. See? If I don't write 0B, what is the output? 410. That is treated as decimal. Okay? 0B. Suppose integer B equal to 36. What is the output comes? If I print, what is the output? 36. But 10 if I write 30. It is octal. Now it is octal. Now see. This is I written 0. 0. See? Now, if I write 1E, what will happen? What will happen? Will it print 1E? No, error comes. 0x, hexadecimal. If you write directly 30, normal, it is decimal. Write this last program. It is binary literal, it is octal literal, it is hexadecimal literal, it is decimal literal. Binary literal, octal literal, hexadecimal literal, decimal literal. Binary literal, octal literal, hexadecimal literal, decimal literal. Only binary literal recently came. Binary literals are introduced in JDK 1.7 version in 2011. Remaining starting version only this one 1.7 version 2011 introduced. Tomorrow morning 9 o'clock, Advanced Java new batch is there. If timing is possible, you can attend. If timing is not suitable, wait for next batch. But now you can attend because tomorrow after this concept exception handling. So after exception handling required, so almost exception handling is going to complete within a 4-5 days. That's what you can attend. Building, even I didn't get that information. Just outside admin you can ask. Maybe in Reliance building, I think. Just ask them. Another building. I think it is not in this building. Maybe in Reliance building. Just otherwise, just outside you can ask him. Reliance building. See, just 0B if you write binary, 0 if you write octal, 0x if you write hexadecimal. If you don't write anything, decimal. Binary literals only 1.7 came. Previously it was not there. Okay. We'll see continuation tomorrow.